Please find our seats. Great. I'm glad to see all the networking and dialogue happening outside. But then again, we are here for the demos, right, as well? So we need to be here at time. So now on stage, we will see Semantum and Draga, and they also have some sort of collaboration. That was something that we really encouraged in the DISC committee team. We want to see collaboration, not competition. Even though we have a sort of competition here now, we call it a healthy competition. So what we were looking at were for these companies here today to get to know each other and maybe start to collaborate to get the best solutions. So now we have Semantum. They will showcase a workflow for automatically creating engineering assets using their diagram digital tools. Their demos are based on creating value after extracting data from legacy design documents. They will first convert design documents such as PNIDs and PFDs and CSCDs into DXP files. They will then demonstrate how they enrich these files with data from other data sources. Finally, they will use the enriched DXP files to create intelligent diagrams in modern CAD systems and generate a simulation model in a semi-automatic way. Please welcome Gerardo Santillan and Antti Wilberg. All the way from Finland.
Thank you very much. I think you already, that was a spoiler, so you know already what we will do. But yeah, nice to see you, and thank you for the invitation. We are happy to be here again. Last year we got really nice conversations, we got also very nice collaboration, and today we are actually showcasing some of the things that are a product of what we had back then. So we are going to be showing first our tools, and then we're going to complete the entire workflow with what Draga will be showing to you. But first, let's just focus on what we did for this year. This is the agenda that we will be following, like the workflow. Some things about our company. Many of you know us already, but for those of you who do not, we want still to tell who we are. We are creating, or we not only do that, but we are now digitizing diagrams for this DISC Show&Tell workflow. So that's what we will be showing. And then we show how we are creating value. Some things related to these brownfield requirements, but also some things related to the brownfield and greenfield requirements. You will see what we are doing. Yeah, so we are Semantum. We are a software development company. We are from Finland. We have been around since 2007. I am joined here by Antti Wilberg, CEO of the company, and I'm, as already know you, I'm Gerardo Santillan. We do a lot of software development. We are mostly software developers, but we also have experts, control experts, modeling and simulation experts. And as you see there, our focus areas are different things, but we do mostly modeling and simulation, and also engineering automation. All this engineering automation started from the fact that we wanted to be more efficient when we were building simulation models. So we wanted to extract data from available material in a more efficient way. And that's how we started digitizing diagrams to extract connectivity attributes from piping and instrumentation diagrams. And then we would use them to create simulation models. This is precisely what we will be showing today. So we have a tool to create these simulation models automatically. But then because we did see the business case on this diagram digitization, that's what we will be also showing. You might even know us better from all those tools that we are creating for that specifically. We have these engineering automation solutions that we call them model broker. There are different variations of this model broker. And I am presenting this briefly before so that when we go to the actual demo, it is easier for you to understand. We have this model broker for diagrams. In a nutshell, we take a piping and instrumentation diagram in a vector format, and we extract its data, and we can create a DXP file, or we can create a table. Then the DXP file, it's up to the customer what they want to do with it. We have had different use cases. In this case today, we are taking the PNID and created a dynamic simulation model from it. Another tool that we have is this DXP viewer. It's a visualization tool that takes the XML, the DXP file, and we can visualize it, inspect different elements of the diagram, and then see, for example, connectivity also, different attributes of those elements. And I'm going to be showing briefly that to demonstrate or to show the extraction results. And finally, we're going to be using this dynamic simulation, this model broker for dynamic simulation that is used to create these dynamic simulation models based on the DXP file. This is done in a semi-automatic way, as Antti will now run that demo. Now we can go to the actual demo. So this is the workflow that we're going to be following. We first import these piping and instrumentation diagrams. Then we configure our tool so that we can identify different symbols, connectivity. All the text available in the diagram can be then used as attributes of the specific instances of the classes that we're using. And then we're also enriching this DXP file using this LLM tool that we have. Finally, we're going to just try to fulfill some use cases that were put as a challenge here in the disk. First of all, we are adding some data to the DXP file so that we can link the 2D and the 3D model. And then we can also create a simulation model automatically based on this information from the DXP file. So now the demo will be some features about this model broker for diagrams, how we are actually digitizing these diagrams. We first configure these patterns. We have graphical primitives present in these diagrams. We configure them. We tell, for example, where exactly we want these symbols to be connected to pipelines or to signal lines or to other elements. And then we also map them into the corresponding DXP class. We can, as you see there, we have this text recognition. We basically can, using regular expressions, take the text that we are finding and then also mapping them into corresponding attributes. And then configuring terminals, we are able to also create connectivity automatically in these diagrams. This is a little demo, small video. We are using videos for this part only. There will be a live demo. You can see here the material. This is the Huldra material that we were configuring. So we first imported into the tool, as you saw. Then we are configuring these symbols, as you see there. Those are symbols for the different elements that can be found in the diagram. Here you can see how text fields are then also mapped to different attributes. And that's how we are also populating all this information in the diagram. Then we are translating this material. You can see in different colors all the information, all the different elements that we're able to identify. We identify connectivity automatically. You can see there are arrows that correspond, for example, to the flow direction. So it is done, we first configure this material, but everything else, all the different mapping of the attributes, all the connectivity is found automatically. You can see there how different text is then also mapped to different attributes. We are converting this into DXP files that we later use. We can visualize it there using this DXP viewer, this other tool that I was presenting also. Here we can see how we are browsing through different elements. We can see all the attributes of this. We can see also connectivity. This is more like a visualization tool and something that we use internally to validate the results of our DXP files. We took the material that was available. We configured the Huldra PNIDs, also the PFDs that were there, and these are actually used for generating the simulation model that Antti will show. Also the Hugging PNIDs. We also took the raster SEDs. We also created files from there. However, important to say that all the files that we created, all the material that we configured was made available in the repository of disk so that other organizations were able to take a look and use them for their own purpose. And we're also happy to see that other companies are also using them, and we were also collaborating with them. We had other, for example, with Siemens, we had, it was nice to have these interoperability workshops with them to ensure that the results were correct. We did not configure the Munin material, basically because it was out of the scope of our own demo, but we could also do it. If you are interested, of course, we can have a talk about that. Maybe just important to say one thing that we wanted to do was also enrich the file. So once we had the DXP file available, we used these large language models, and then we extracted data from the datasheets that were available in the repository of the disk, and then we also, for example, took this datasheet of the pump, of one pump, and added all the attributes corresponding to nominal data. And that's how now the DXP file that we created also includes that information. We also did the same and followed the same approach for populating, for adding additional data required for creating the dynamic simulation model. We can see here how this is working. Maybe I just go a little bit faster there. So this is the datasheet that was made available. We are using just this large language model tool that we have. We extract data, we show it there in this machine-readable format, and then we, as easy as we are just querying the tool with these queries, also written in natural language, we take, for example, this specific attribute, we copy the results to a clipboard, and then using our DXP viewer, we are also able to inject this into our DXP file, and then you can see there the result, how we are also adding all those additional attributes to our DXP file. This is how the enriched material looks in comparison with the just DXP file obtained from the PNID. But now my colleague Antti will give this demo.
So hello from my behalf also. So we wanted to have something extra since we did showed most of this what I was just saying also in the previous event. So now we wanted to show that once we are able to extract this high quality DXP semantic presentation of the PNIDs, we can then use them in many ways. And for example, we can semi-automatically generate a dynamic simulation model based on this data. Some use cases for dynamic simulation, obviously, we, like in many cases, we want to do OTSs, and some other kinds of digital twins for maybe tracking or even optimization of processes, maybe for virtual sensors, for detection. There are many use cases for dynamic simulation model of a process. And the idea here is that we want to shorten the model creation time, since it's quite laborious to actually create these dynamic simulation models. There are many labor intensive steps there, which we try to, with this tool, streamline. And what we use the PNIDs in DXP format that we have converted, some equipment data sheets, and we also need material and heat balance sheets, and could use, if they were available, some steady-state simulation models also available from that material. Yes. So just quickly, here's a picture of this. So we are using this, as Herard was showing, the model broker for diagrams and the parameter extraction part. Then we have this tool that I'm going to actually live demo here for your pleasure, since everyone loves live demos. Actually, yesterday I was planning to show a video, but someone convinced me to. Yeah, it might be entertaining. Yes. Yes. So with this tool, we can create these dynamic simulation models. Of course, after we have generated, we need to finalize, tune, and test. And we also have tools for that also available, but we are not really now concentrating on that. So let's see. Where do I see? I'm not seeing. Well, okay, I can see it from here. All right, so here is our tool. We have here, I have selected now just 2 of the Hugin A scope. We actually planned to create a full simulation model of this, but there was some data missing, some parameters missing, and then in the end we thought that it's not really like worth spending all that time in inventing the data that we don't really have. But yeah, so the idea here is that we take these PNIDs, then we are kind of first painting the resolution. It's always the demo effects. Yes, so I can show that. Hopefully. Oh no. Well, yeah. Okay, so we have this painting tool which we are using to select the scope. So basically we are painting, selecting what parts of the model we will include. Now I have a demo effect here, so I won't be showing that. Then basically the idea is that we are translating one-to-one here. So when we have like pumps and valves here or heat exchanger, we will actually do a one-to-one mapping. But we do have some rules here that can be used to modify, but this is most effective when we actually can just do one-to-one mapping. So that's what we have done here for these two models. And we are creating a simulation model for this Omegaland visual modeler, which is a dynamic process simulator, well suited for oil and gas processes. And for example, here we have a correspondence of these pumps that we have here and the heat exchanger. This is the visual modeler version of this, and the other connected. I can't see the. I can't find the mouse. Okay. Yes. So for the other diagram, we generate a similar topology. In this case, we didn't have that much like numeric values, and that's why we didn't kind of finalize this simulation. But we can still see that we are transferring here some properties, let's say, for the valves, CV values needed in this visual modeler, and we can see that we have that. If we can see that in the properties of this DXP file, we have enriched there these CV values. So they can be transformed into the simulation model. Maybe in the future I will then also, or some future event that we will finalize this and show actually some simulation results. But this was just and I figured out there will be some problems like with now the resolution, but that's for your convenience. All right. So just to recap, so we can use this tool. We are using it internally for our deliveries, since we are doing for example, these OTS or DigiTwin deliveries, and we're using it internally at the moment to do this bulk transformation of models. We can do 3 different simulators at the moment. This Omegaland, which I was showing here, and also Petrosim by KBC, and then APROS by Fortum and VTT. That's more suited for the process, power industry. Yes, I think we are short on time, so let's move on.
Yeah, just briefly recap also on this demo. Well, the last part is how we are linking 2D and 3D models after enriching the material. But I think Draga will show anyways a big part for that. So just to say that our collaboration with them is also part of our collaboration with them. And yeah, just to say that we have this workflow now, but the story continues. So happy to give the floor now to Draga for them to show what is the rest of all this.
Thank you.
Thank you.
Thank you.
And now we have Arsalan from the technical committee. Please come forward, Gerardo.
Thank you so much for presenting, guys, and also taking the challenge to do a live demo. That was really good. And I think both Geir and Per Christian said that we have legacy assets in Norway. And this will help a lot in also lifting up the data quality on those assets. So thank you so much.
Yeah, okay.
Thank you.
Thank you. Okay, so now we can welcome Draga. They will use the Munin datasheet for the DXB file and the AML, use of ChatGPT, show integrations between SCD in an AML format and DXB and PNIDs. And please welcome Kent Andersen and Alexander Kushnenov.
Thank you. Yes. Yeah, we are pressed on time and we have lots to show, so I'll just crack on. A little bit about us. I will include this slide. I won't talk too much about it, but you can read up on it later. The most about our company is just that we do information and content management in digital twin initiatives, and our customer base is usually owner-operators in the energy sector. We specialize in data warehousing and digital twins, 4 locations now, with a new office in Singapore this year. We also have an IP holding company that's holding all our IP, which is called MEMS. So not to confuse you, it's just openness, 0-person employee, and it's primed just for investment, and that's why we keep it separate. Yeah. And what differs us from a typical IT company is that about 70% of our staff is engineers, so they have domain knowledge within the different disciplines of engineering. And we really understand the data and the content, and that helps us dearly in typical project like this, especially in the brownfield area. We also help out in the greenfield, but when it comes to old data, you have to come talk to us. Yes. We are a service company and a project company, but we also do a little bit of consulting just for information, and we're also involved for openness sake, in the datasheet and IMF project by DISC. And we previously also contracted a lead for the DXB initiative. So we have been involved in this fair for a while. These are our 4 cores. The top left corner is the place that we are focusing on now. It has to do with conversion of PNIDs, data migration, and digital twin content. We have our tool, which started its life in 1979 in Statoil. But long story short, it ended up with us in 2020, and we now own the source code, and this is sitting in our MEMS company. To whoever is interested, I will add this slide to the presentation later. So we bought it in 2020, and what have we done with it? We have started reprogramming it to a modern language. It's using the later Oracle and started converting it to C#. We made a new backend. We're now also replacing the class library to CFOS out of the box. And also for future, we want to put it in the cloud. And this is kind of in the timeline we are now. We want to do all documentation, drawings, DXB, 3D, whatever, in a cloud, in an internet browser. And that's with no plugins, no installations, just log on and your access depending what you'll see. And this decision made a basis of what we call a module that we call dynamic render. Initially, when we started out of the box, our tool could create loops and block diagrams, nodal diagrams, and typical isometric diagrams. So we have our own database, and we wanted this dynamic renderer to sit on top and auto-generate these drawings, because these drawings are based, it has a start and a beginning, and you can use an algorithm to place the various objects in the drawing and make connections between them. So that's what we call algorithm-driven drawings. And also we wanted to strengthen any collaboration or communication features as well. So since it's browser-based, we can integrate this with Teams, for instance. You can sit in a team, you can have a group of documents, or you can even have a team per PNID, and you can discuss and review and approve. So this is something we've done. And since the disk came online last year with some challenges, we include the schema-driven drawings, which is typically DXP or automation markup language, or it can also be XML or JSON or whatever structured file. We have our own database, but we have APIs to the market-leading vendors. So it's a generic module and can sit on top and work in your company intranet. On top of if you have something from Hexagon or Aviva or StidLoop or PCSLoop or Ocotec solutions, this dynamic render can sit on top and act in your should I say, Power App level. Yeah. So. Yeah, it can sit in the private cloud, public, hybrid cloud, and this is kind of the overall view. Virtual drawings, in the modern framework, model access from anywhere. That is basically the case. Our agenda for this year. We'll do a small recap from last year, just so there are a lot of new faces. So we want to do a little review, talk about, again, our collaboration with Semantum, and what we have done there. There is a lot of three-letter abbreviations here, you know, SCD, AML, PNID, IMF, and things like that. So I'll try to spell them out. Yeah, we will also show using our dynamic render as an authoring tool for DXP, and how we can use that one to enrich data and collect data from many sources. We will have a small AI connected to our drawings, so we will show how that also works in real time, and so maybe some surprises there for you. We will integrate the system control diagram, SCD, in the automation markup language and the DXP formatted PNID. So we will combine those two and have them in one view to kind of see how that will work. And also we have an integration to 3D models on the wish list. We used the Moonin dataset because we had a limited post of time. We were supposed to show an actual project where we have used the model broker from Semantum to convert a facility and converted them to a smart plant, but because of today's security challenges and disturbances, we are not allowed to show their PNIDs on the stage. But we can possibly arrange some demo later if somebody would be interested. Yes. We will show integration to the EQ Hub and also the IMF breakdown. We're going to select the temperature transmitter, find the IMF blocks, and populate the IMF based on various XSpecs. I had a slide before to talk about the IMF, but it was very well presented by PCA this morning with a steel fan and or a metal fan. Yeah. So we will. I don't need to repeat that. And lastly, but not least, last year we got some feedback that our result looked exactly like an old school drawing. So they wanted to see data in different ways, and that is what we have tried to do in the last there. So a little bit of a bonus in the end. So I mentioned we have worked with Semantum. We have further developed our drawing engine. At the same time, we have now seen the necessity of having a symbol manager that can connect to Aviva, SmartPlant, Comos, Ocotec, and synchronize the symbol so that the symbols are properly configured everywhere. So this is an ongoing activity, and right now we are focusing on some Hexagon products, but also we will look into Aviva and Ocotec later. We have also executed an actual project, and we have used the model broker, created the DXP XMLs. We have fixed some of the content and added information from other sources, imported it to a P&ID database that was a copy that we got from the customer in our environment, and then pushed it to the customer. So this was the first project, but I've seen the next project, we can just push it straight to the customer. We don't need to go through our database, possibly. We can do a demo on this also later. This is the model broker that was shown by Semantum. We took the files, we mapped and captured all the various symbol patterns, and then we could view the results with the relationship, etc. So if you've done this correctly, we could see that over there. There's also a video for those who are interested later to look at it. Yes, there were challenges, you know, in doing this. We found that symbols that look the same are not the same. Come from a computer point of view, there are slight differences, and some contractor may have used the same symbol, but they have made it themselves, so that it's not matching 100% computer-wise. And even though Model Broker does some tweaks and it helps in this matter, it's still, we need a lot of valves, you know, and things to make it, make all the, because these drawings has been living in AutoCAD and MicroStation for 30 years. So there are some variants there. So we have trained our team in our department in Asia that is now become expert on doing this, and we can really scale this up now. There are also challenges where symbols are very scalable or parametric and has been stretched and going up and down. Also types like auxiliary graphics, like this, I think it's a drip tray, this yellow big thing there. This doesn't have a tag, it's just a dumb object sitting there and displaying a function. And this is also something that we need to deal with manually, one by one. And of course, all of this has to be mapped to the corresponding DXP class. And that is the final thing that we do. We then bring the result into our dynamic render module and validate and close any gaps. We had challenges with many different symbol types, and then we closed the gaps, made the data good enough to enter into an engineering tool, and then we have exported into a tool that's delivered by Hexagon. Yes, and now over to our demo. I will have this demo done by Alex, but if we could keep both microphones on, that would be great. Yes. So, we're first going to show a little recap from last year. We're going to show some loop drawings. This is initially how we started. And this, again, is this algorithm-driven drawings, where we have an algorithm that places a symbol and it runs through the relationships from the left and all the way to the control system. So the instrument's on the left, and it has some terminal strips. There is connected a wire, the wire is in a pair, the pair is in a cable, etc., and so forth and so on. So there's an algorithm that calculates and places this on a drawing. So it's pure algorithm driven. And this drawing does not exist. This is not a file. This is not a PDF. This is pure data streamed from the database in real time. We also made block diagrams. As an example, we did some electrical lighting block diagrams. This is also streamed real time and distributed using a different algorithm. You can see the fuse box to the left and connected all the lamps, and there's a lot of them now since we are using LED, with all the cables in between, and they're all distributed again by using an algorithm. There was also a request for the connection diagrams, but we saw that using them as a diagram would be not so efficient. So in case we define just like a view, so we can see every terminal strip and we can see what is connected to every terminal, and find available terminals to possibly find where is the shortest path to the control system if you want to hook up a new symbol, for instance, in a brownfield scenario, I want to do modification. We did also a single line. Again, this one is also streamed straight from the database. And yeah, it's what it is. We did the PNID, so I'm going to skip that. We're just going to go to the SCD. We're going to do PNIDs for Munin, so we can combine there. Yeah, and here was SCD. This file that came was a mix of Visio file and AML or something like that, I remember. So we did this, and then we started playing around with it. So the first thing we did was we switched off the color. Just as a thought experiment, can we change it? And yes, we click a button and we can switch off the color. And what did we just do? Well, we didn't change anything, but we have changed how I wish to look at the data. This is important. So the data is still the same, but the view has changed for me. So then we started playing around with new things, maybe like review functions and things like that. And we added that on top, so we could compare this revision or version of the drawing with a previous version, automatically mark up with color if something has changed between the older and new, and made some comments here. There was also the last function we tied together with just a thought experiment again with commissioning packages, where we automatically can put them also on top. So we're all working on the same data set. We haven't really changed the data, but we have added more connections to the data. And with different hats on, you can all work on the same data set, just using your tablet, phone, or computer, anywhere. Lastly, we were asked by a customer to make some sort of red line markup feature. And I didn't really like to do this because this is, again, as was said this morning, document workflow. We're trying to get away from documents, but again, of course, the customer asked for it, so they will get it. But we see the future that we need to start thinking about revising the equipment. We can do a revision on this vessel, and just approve that change. You don't reapprove the entire design. You approve the change, and this is where we think the future is. Yes. So now over to the new data set. Yeah. As I mentioned, we used the Munin data set. We were supposed to show some customer stuff, but yeah, unfortunately, this is what we have. We import the DXP formatted Munin file. We are working on VPN, so it's a little bit slow. Yeah, so see, again, this is in an internet browser. This drawing, though, is not algorithm-driven, right? So, because an engineer has actually placed an object on a specific point on the drawing, they made a rotation, they've done something, so the computer cannot automatically distribute this drawing. And there is where the schema comes in, and this is the DXP schema. It can be other schemas, but we have used the DXP schema, and that's how we interpret the drawing to graphically show on the drawing. So this is Munin, one of the Munin PNIDs. We had a question about looking at properties and adding information from other sources. And this is the properties available, for instance, for this instrument. And then some of you asked for IMF. So IMF was explained this morning. They had these different aspects, like product. What seems to be a light green now is actually a cyan color, is a product aspect. The yellow one, a functional aspect, and the magenta is location aspect, and so forth and so on. There is many aspects to our different points of view to a piece of equipment. We're going to go back to the product and see if we can connect this up to EQ Hub. We're missing a EQ Hub ID. So Alex will key that in. Of
course.
And then suddenly we are populated with the available data from EQHub. So this is all real time. Yes. And then a little funny challenge we had. We see we have a little green little button down there in the corner, like a little chatbot. So we tried to make a function, and now it works on right click, you know. What is it? What is it? You know, and then we can use the chatbot to help us. Oh, so this is the process shut down, and it shuts down a valve, and the valve there, yeah, it's hyperlinked. So can you click that one? Yeah, it jumps to the valve. So this is showing how a chatbot can work. We can maybe ask it more questions. Are there more shutdowns?
Yeah, it's good enough.
Yeah, sure. There are 3 versions on this drawing. So we can then click on maybe one or the other one. Yeah, and we can see how they're all connected with the color. Yeah, so that is how we potentially can use a chatbot in the future to help out and read and review a document. Yes, and then there was a question about automation markup language files, which is the system control diagrams. It's formatted as AML. In short, maybe we can open one of those. Yeah, we're running out of time, so I'll be quick. So yeah, it looks like the same PNID, but now we have combined the data. So if you click any instrument, again, VPN, and then you can see the SED functions projected on top of this instrument. Can you click another one?
Just 1 second.
Yeah. So then we basically don't need the SED anymore, I think. Well, maybe we need it. We can keep it here in this language. So now you can combine the information from both sources and have one view to watch the data, which we think is possibly the part of the future. Yes. Yes. So we'll quickly show a link to 3D. I'm not sure if it's time. We can quickly. You can just right-click a valve, for instance, and is it hanging? 3D. This 3D viewer is something we borrowed from friends of ours. They're called NovoRender, and we like their solution because they're also web-based. They're very light viewer, and it works really well together with our online thing. So yeah, we found the valve in the 3D, and happy with that. We'll skip to the next one. If you want more information, I can tell you later. And the last but not least, yes, we're going to show data in different ways. So last year, people said, oh, the drawing looks exactly like my drawing. So let's find another way of showing it. Here you go, Alex. Yes. It's not showing. Here we go. It's lunch. It's a fruit salad. This was just something we want to play around with because, we wanted to do some simulation. So if we had some real-time data, we could push it in, and we wanted to make the fruit explode or something if the pressure got too high, but there wasn't enough time. But it's unlimited what we can do with this, so yeah. I think we'll take it from there. Thank you, everyone. Okay, bye-bye.
Wow.
So Arsalan?
Wow, guys. So many points scored. I just want to mention the collaboration part, really, because it's one of the pillars in DISC. Many points for that, but actually showing what you said yesterday, Kent, the real single source of truth, connecting it all together. Wow, really good presentation, guys. Thank you so much.
Thank you.
And a comment.
Just a short comment. The feedback we gave these guys, all of them, is of low quality. we haven't been modifying or configuring the data for the DXP files or the IMF files or any other files in particular for this show and tell. It's out of the tools. So what they are showing us is magic.
Yes, so what they showed was magic. But if we look back some years, this was also magic. Can I have the sound?
And to unlock the phone, I just take my finger and slide it across. Right? Can you see that again? We wanted something that you couldn't do by accident in your pocket. And just slide it across. Boom. And this is the home screen of iPhone right here. And so if I want to get in the iPod, I just go down to the lower right-hand corner and push this icon right here, and boom, I'm in the iPod. I want to get home, I push the home button right here, and I'm home. Back in the iPod, I'm back in the iPod.
Wow.
Playlists, artists, songs, videos, and more. I'm an artist right now. Well, how do I scroll through my list of artists? How do I do this? I just take my finger, and I scroll.
Yes, you get the picture, but it's not many years that this was magic. So we need to keep on pushing the boundaries and think about Einstein that actually challenges the absolute truths in things, right? So we need to keep on pushing them. So I want you guys during the lunch now to ask yourself, when was the last time me or my organizations really pushed some, these are the truths, challenge those things. It might be quite a long time ago, and you might never done really that, to challenge the absolute truths. So have a think about that during the lunch. Now we will have lunch for an hour, or we have 5 minutes overtime, but we'll be back here at 13:00, and then we will have WebStep and Ultimindtree for the demos. So they need to be present here 10 minutes prior to the timing, so that they get their mix. Okay? So now go out, stand with your boots, connect with people, and enjoy the food.